Hello, welcome to Leetcode Solver. Today we are going to solve 11th problem in May Leetcoding Challenge, and the problem name is plot fill. An image is represented by 2D array of integers, each integer representing the pixel value of the image 0 to 65535, given a coordinate SRSC, source coordinate, representing the starting pixel, of the plot fill. And pixel value newColor flood fill the image. To perform the flood fill, consider the starting pixel plus any pixel connected four directionally to the starting pixel of the same color as the starting pixel. Plus any pixel connected four directionally to those pixels. Also with the same color as the starting pixel. Yeah, that definitely. And so on. Replace the color of all the aforementioned pixels with the new color. Okay, nice. At the end, return the modified image. The image should be modified with the given color to the all the values which will be four directionally connected from the given source xy. Well, if we go to the, if we starting is 1 1, this one, then this one 0 1 1 1 here, then it will cover this as well, this as well. That is there. Okay, so answer will be 220 201. Well, so only last one won't be affected, otherwise every other coordinate will be affected. See, let's see. So if starting coordinate is 1 1, that means this one, then yeah, then we have to change to color to 2, so it will be 2, and it will do the same for all four direction, and all those newly colored will also color the four direction like this, but in order to color they should have the same color like it was before. The initial coordinate has 1, and it can only color all the four connected values which have the color 1, and the color 0, so it can't color to the 0 because it doesn't have same color like it had before, which is 1. So that's why it will not do anything to 0, not do anything to 0, not do anything to 1. That's why it has color 1, but it is not we are only coloring four direction. We are not considering diagonal direction. Otherwise, if we consider diagonal direction, it would have been 2 as well, but we are not considering diagonal direction. Well, so the straightforward and the most common way of solving this kind of problem is using either depth first search or breadth first search, and the complexity of solution will be big of the grid size, which is basically n cross m, or n is the size of the row, m is the size of the column, and space complexity would also be the same if we use a q to, I mean, in case of BFS and DFS, we will use stack, as well as we will use extra memory like for to hold the already visited value, because we are not gonna visit again. So that is why we need to hold a matrix of booleans which indicate whether the current position, I mean the coordinates, has already been visited or not. Well, let's go with the breadth first search this time, because we already solved so many problems using depth first search, as well as depth first search may not be the good solution in case we have like high grid size is very high, then the stack memory may give us stack overflow. So we try to avoid recursion as much as possible. Let's do queue based solution. Well, so BFS, for that we need a queue which will hold coordinates. So let's say pair of integers, say q, and we need a visited array, say vector of two-dimensional vector of boolean type. So visited array which is of size, let's define size. N is the size of row, so if size of row is empty, then we don't need to modify our image. So modified image will be image itself. Image, okay, well, otherwise we will calculate column size, which is 0.size. Okay, and let's define boolean of size n cross m, and let's fill up everything with the false not visited initially. And let's start our queue. While queue not empty, we use queue to implement breadth first search, and we'll extract the top one and go through all the direction and do the same thing. So let's extract the top value, top x and y, q dot front, the front element in the queue, and first value is x, and y will be q dot front dot second. Now we have x and y, and say initially we need to put x and y in a queue. Let's put given x and y, the given source. So initially this is the source of the queue, which is in the front of the queue, and let's make them visited, which is already visited. So srsc is true. All right, and now we extract these two values. Now we want to go through all the directions, so let's define, as we already discussed in previous problem, we can either write down four if conditions to go to the four direction, or we can just iterate using a direction array. So let's form a direction x, which is like indicate to go to up and down. In up and down, x won't be changed. Up and down, left and right. So direction y, in case up and down, direction of y will be changed, and in other cases y will remain same, nothing changes in y. So let's formulate our new coordinate. If we new coordinate, say nx will be equal to given x plus direction of x added by I in ith position. So if we add that, then we'll get new x. Let's get new y, which is current y, and direction of y I, and let's see if it in the boundary condition, say nx is less than equal 0, nx is less than r, new x, new y is less than or equal 0, new y is less than c, and initial color, say color is image of srsc, so this is initial color. Say we can also say initial color, so current color should match with the initial color. Say current color is image of nx ny should be equal to initial color. Okay, nice. And it should not be visited before, not visited of nx ny. If this is the case, then we can simply go over there, visit there. We are keeping track of visit array so that we won't go through infinite loop. So it is visited. Let's make it true, and let's update our image to new color. New color is given as a new color variable. Well, in C++ we can write down something like this: new color variable naming, and we have done this. We have to update our image as well. After finding initial color, let's update our image, the source image coordinate srsc to new color. Well, color. Awesome. Sounds good. Let's post to the queue again. Anything we missed? Looks like nothing. We are done. Let's return. What do we have to return? It's the same image. Let's run the code. If it compiles, what happens? I can't submit. Let me reload. Looks like internet problem. Okay, let's run the code. Comparison error at line number 24. Okay, not R and C. We declare this as a N and M, row and column. Time limit access. Oh, sorry, we forgot to pop. After extracting front element, we have to pop out. Okay, 111, 120, 101. Nothing changes. Okay. Uh, we have to. Okay, we already changed it. What's the issue? N and M. Yes. Greater than equals 0. Show difference. No difference. Let's submit. Well accepted. Nice. 20 millisecond, 14.4 MB megabyte. Awesome. Well, thank you so much for watching this video, and thank you so much for tolerating the disturbed internet connection. And yes, if you have any alternative solution in your mind or anything you would like to say, please feel free to comment. See you in the next video. Have a nice day.